Number 9 wants to know which of the following elements has its highest energy subshell completely full. So let's see, remember that this is the S subshell area, this is the D subshell area, the P and the F. So let's look at sodium. Sodium is right here. Its highest energy orbital is going to be a 3s because it's in the third row. 2, 3, 4, 5, 6, 7, and so on and so forth. So it's in the 3s area, but it's not full because it would need to go all the way over to here to be full. So that one's not the answer. Let's look at aluminum. Aluminum's right here. It's in a 3p area, and it's not full either because the P would have to go all the way down to there to be full. And then chlorine is right there. It's also in a 3p, but it's not full. And then we get to zinc, and sure enough, zinc is going to be the answer because it's in not a 4D like we might expect, it's in a 3D, but it's 3D10, as in if you count up the electrons all the way across, it's full. So that turns out to be the answer. Which of the following isoelectric species has the smallest radius? Isoelectric means they all have the same number of electrons, and I think you can see that that's true. Like, look at the neutral one, argon. It's right there, has 18 electrons, while chlorine minus 1, well, chlorine's right here. If it's minus 1, it gains 1 electron to become like argon. And if you go through that process, you see the first one, A, sulfur, has gained 2 to become like argon. So you notice that they all have an electronic structure that looks like that, and since they're in the third row, all the way across, we're going to draw 3 rings to represent sulfur, because we're just going to look at the first one. So I got the nucleus in here for sulfur, 1, 2, and we need a third ring like that. And there's 2 electrons in the first row right here, 1, 2. There's 8, 1, 2, 3, 4, 5, 6, 7, 8 in the second. And we get to the third row, and it's 1, 2, 3, 4, 5, 6 electrons in the third. 4, 5, 6. So sulfur looks something like that. And realize that every single one of these compounds is going to have the exact same electron structure. The only difference between them, of course, is what's in the nucleus. And in sulfur, it's going to have 16 electrons or protons in the nucleus. For chlorine, it's going to have 17 in the nucleus. I'm just looking at the atomic numbers. And argon is going to have 18, and potassium plus 1 is going to have 19. So if potassium has 19 protons in its nucleus, it will be able to pull the electrons in more, and therefore it will be the smallest atomic radius. So D is the answer. What is the most likely electron configuration for sodium in its ground state? Well, that should be relatively easy. We can just write it out. You notice they're doing full electron configuration. So we always start at 1s2 because remember we're going to number the rows 1, 2, 3, 4. We start in row 1, and this is the S area over here. So 1s2. Then once we get across to there, we hit the second row right here, and that's in the S area as well because remember S, D, P, and F. So we're in the 2s area right here, and there's 2 blocks, 1, 2, representing electrons. Then we go across over here. Now we're at the 2p area, and there are 1, 2, 3, 4, 5, 6 electrons. And then we get down to the next area, which is where sodium is, and it's in a 3. It's in the s block. And there's the first electron there, so there's just 1 electron. So that's what it should look like. Let's see what matches. Nope, A didn't have the 3s1 at the end. B didn't either. C has it, so that looks like that might be the correct answer. And D has 3s2, so that's not. So C is the correct answer.